Hello, welcome once again to our channel. This is the Mati channel, and we are focused this time on what? On the Form 3s, those who are getting ready to write their BEC this year. Now, today we have something special for you. You have to sit back and wonder because this has been a problem for most students for so many years. And we are going to tackle something in science that is very important. This is one aspect of science that most students find it very, very well difficult to deal with. But here we are going to break it down. The promise is that at the end of the video, at the end of the lesson, you will be able, somebody's asking, so what is he coming to do? You'll be able to name all compounds. You see, naming compounds has become an issue for most of you. But like I always say, when you listen to the principles that we give here, you'll be able to name any compound at all given to you at this your level. It all needs, or what you need is for you to listen and apply what we say and practice. Always I say this. Once you practice, you are good to go. Now, so what we are going to look at here is how to name compounds. So naming, that's what I'm going to do here for you. Naming of chemical compounds. Naming of chemical compounds. I urge you to sit down and listen to these over and over and over for you to be able to understand. Because in the BEC, you will have to name some more compounds, and at times it's very challenging to most students. So let's not waste the time. Let's get straight into it. Okay, good. So in naming compounds, there are certain things you need to know before you can name any compound. If you don't know those things, you can't name the compounds. You can't name them. And I'm going to explain those things before we even start naming the compound, because without that, you cannot name. When you are asked to name a compound like of this sort, SO4 2-, and you know the rules of certain things involved, then you can't name this. It's tetraozosulfate 6 or ion, tetraozosulfate 6 ion. We'll know how to name this thing at the end of this. I hope you get the point I'm making here. Good. Let's go straight into it. So the first thing one needs to understand here are what? Are atoms. Something that I know you know. But let's go through it. You have to understand what atoms are. What atoms are. Now, when we say atoms, what are they? Now, these atoms are the smallest particle of an element that will take part in a chemical reaction. The smallest particle of an element that takes part in a chemical reaction is referred to as what? An atom. Now, all these atoms you see here, an atom is assigned a number. So, if we take this, if I write this for say an atom is the smallest particle. So, an atom, the smallest. Remember, without these things, you cannot get what I'm going to do here. So, stay back and listen carefully to the end for you to name them. Because when you know this, it's forever. You go to SHS and you still know how to do it because the same thing they're going to teach you. So this is an advantage for you to learn it better. So the smallest particle of an element is what? It's an atom. Good. Now, I said every atom is assigned a number. We give atoms numbers. An example of an atom is what? Is hydrogen. Is helium, Ca, calcium. These are atoms. But these guys are assigned numbers. We give them numbers, which we call the atomic number. I am summarizing everything for you. Because this is what? This is a Form 3 class. I'm summarizing everything. So get to know that there are atoms which are the smallest particles of what? Of elements. Then these atoms are given what? Numbers. Those numbers are referred to as what? Atomic number. Listen, you understand this. They're referred to as well atomic number. What's atomic number? It's the number or the number assigned to them is based on subatomic particles they do have. They have subatomic particles. When we say subatomic particle within the what? Within the atom. Inside the atom, there are 3 particles. There are 3 that's what we call them subatomic particles. These are particles found in the what? In the atom. Example, we have protons. And these protons are positively charged. They are positively charged. We will need all these things, so you take time to understand. If you don't understand anything, just send me your questions in the comment section. I'm going to answer them. So take time, let's go. So I'm saying that we have atoms, these atoms within them are particles. In fact, they are smallest particles. Within them are also particles. And those particles are called the subatomic particles. We have three of them. We have protons, three protons. We have electrons. We have electrons which are negatively charged. They are negatively charged. So I use plus for these. So protons, so don't forget P for what? For positive, so plus. E negative, so minus. These guys are minus. Then we have the next group of subatomic particles called the what? The neutrons. Now, if you listen to their name, neutrons have no what? They have no charge. They have no charge. So these guys don't carry any what? Charge. So positive, negative, and what? And no charge. Now, the number of protons and electrons an atom has determines its atomic what? Number. So that if I have 3 protons, then my atomic number, which is normally represented with what? With a Z. Listen, I just want to break this thing down for you to understand. So let's take it gradually for you to understand, because this is one of the challenging things for students. I want to take my time for you. For you. It's all for you. Good. So we are saying that the number of protons and electrons you have tells us your atomic what? Number. So if I have 3 protons, then I am atomic number what? Number 3. You know what I'm saying here? I will need this. So you need to listen to understand. If my number of protons are 20, then my atomic number is what? Is 20. So what's atomic number? It's basically the protons and electrons, or the number of protons and electrons in an atom. The number of protons and electrons you have gives you atomic number. So what have we learned so far? We have learned that we have atoms which are the smallest particles of an element. Within the atoms are particles, and these particles are what? Are called the subatomic particles. These subatomic particles, we have protons, electrons, and what? Neutrons. And the number of protons and neutrons an atom has determines the atom's atomic number, which is represented with Z. We give an example that if I have 3 protons, then my atomic number is what? Is number 3. If I have 20 protons, then my number is number what? Number 20. Hope we're getting what is going on. Hope you understand this. Good. So in the note you see there that the number of particular subatomic particles, that's electrons and protons, gives you atomic number. Now, what are they? They are particles within the atom. I've listed everything there. So if you look at the structure of the atom, this is how the atom is. The atom has a center called the nucleus. So this is the center of the atom, and we call this the nucleus. The nucleus. In the nucleus are 2 of the subatomic particles. 2 of them. The protons and the neutrons are found in the nucleus. So in the nucleus, I have protons and what? And neutrons. Listen, we are looking at the structure of the atom. Around this nucleus are shells or orbits. I will need this thing, or energy level. I will need this thing badly. Badly for you to understand. I'm taking you gradually through the process. Good. So I have my nucleus. In the nucleus, I have protons and what? And neutrons. I said around the nucleus are what? Are shells, orbits, or energy levels. Now, these energy levels are those that carry the what? Electron, or they contain the electron. That means that electrons are located in the what? In the shell. So this is a shell. I hope you understand what I'm saying here. Very, very important. This is a shell. And the electrons are located in the what? In the shell. I hope you get the point I'm making here. That's what I'm saying. Very, very good. So we've got to know right now that these guys in the atom, this is how they are represented. This is where we find our protons, and this is where we find our electrons. Now, putting electrons, this is one of the best parts I like. Putting electrons, in other words, configuring electrons into the shell is referred to as electronic configuration. So when I put electrons into shells, then I have configured the electrons. Where can electrons be found? Electrons are found in the shell. So when I put an electron into the shell, what I've done is I've configured electrons, configured and putting them into shells. And that is what? Electronic configuration. Electronic what? And that's the next thing I need. After understanding what atoms are and knowing, the next thing you have to know is electronic configuration. We are going to use that. But before you can know electronic configuration, you need to know the atomic number. That's how I came to pass here. Good. Now you have to, from here, you have to understand, you have to know your first 20 elements with their atomic numbers. If you don't know them, go back and go and learn them. Learn them so that you can now follow. Because wow, if I mention any element, number 20, like calcium, you should be able to tell me its atomic number. When I mention magnesium, You have to tell me is what? Number 12. Aluminium, number 13. So number 13 that I've written here, these are the atomic numbers of magnesium and aluminium, respectively. Now, this guy tells me that magnesium will have 12 protons, and this guy will have 13 protons and also electrons, because that's atomic number. Okay, very, very, very important for you to know this. So the arrangement of electrons in the shells of an atom is referred to as electronic configuration. We are configuring the electrons into the shells. Also known as orbit or energy level, only takes a maximum number of electrons. This is the point I need you to know. In configuring the electrons into the shell, yes, we want to put electrons in the shell, but every shell, in fact, we are looking at 4 different types of shell. So this is the first shell, the first shell. This is the second shell. We also have a third shell and a fourth shell. For now, let's end it here. So these are third shell, and that's our fourth shell. Very important, very important. Now, each of these shells, I hope you are getting this. Now, let me do this thing better here. Hope you've written what you need here. I need this aspect so badly. That is why I'm coming to draw it again for you to understand. I'm saying that these electrons are configured or are placed into shells, and these shells take a particular number of electrons. Putting the electrons into the shell is referred to as electronic configuration. So what is electronic configuration? It is the arrangement of electrons into the shells of an atom. I hope you get the point. And you arranging them based on the particular number of electrons that goes into a particular shell. Listen, based on a particular number of electrons, or the number of electrons that go into a particular shell is referred to as electronic configuration. What I've just said means that every shell has the maximum number of electrons it can take. Every shell has the maximum number of electrons it can take. Now, the first shell, which we call the K shell, so the first shell, which we call the K shell, the shell can also be energy level or orbit. The K shell takes a maximum of 2 electrons. What do I mean by that? That means when I put 2 electrons on this, I can't go further. If there are more electrons, I have to place them in the next shell. The first shell, K, is satisfied with 2 balls of K, or 2 balls of electrons. Let's put it that way. And once you have 2 electrons, you can no longer take in any electrons. So anything must go to the next shell. How can you get it? That's what I mean by maximum. The maximum number of electrons you can take is what? Is 2. So once you have the 2, you cannot take in. If there's more, they'll give it to the next shell. The next shell, which is the second shell, which is the L shell, will take a maximum of 8 electrons. Once again, when I fix 8 electrons into this shell, and the shell is fully filled, that means this shell has all the electrons in it. It's full, and there are still more electrons. I'll go to the next one. You can't put 9 electrons on this. Neither can you put 3 electrons on this. The maximum, listen, the maximum is 2. So you can't go more than 2. That's what I mean by that. Then the third shell, which is the M shell. Let me see the third shell, which is the M shell. M shell will also take a maximum of 8 electrons. As I'm summarizing this, as I explained, but this one can take more than 8. But I'm explaining something, that's why I don't want to go deep into that. We can look at it, it can go more, it can take more than 8. But for the purpose of what we're doing, we go with the 8. And the fourth shell, which is the fourth shell, the N shell. The fourth shell, which is the N shell, KLMN shell, will also take a maximum of 8 electrons. But under normal circumstance, it takes more than that. The N shell will take so 8. I hope you get the point. That means K takes 2, L takes 8, M takes 8, and N also takes 8. These are the maximum number of electrons that can go onto a particular shell. I hope you understand. This is very important for you. I have all the notes written here. Look at it, and I've explained them well. Now, there's one thing you have to know, that the last shell of any atom, based on the arrangement, let me just perform an experiment with this. Let me perform some experiment with this. Let me take an element like oxygen. Oxygen is number 8. Number 8 oxygen. That means the atomic number 8 means oxygen has many protons? Has 8 protons and how many electrons? 8 electrons. I hope you're getting the point. We said that earlier. Good. So in that case, what are we saying here? If we want to write the electronic configuration for this guy, then this guy's K shell will take how many? 2 electrons. There are still left with 6. Then this 6 will go into the L shell. The L shell still can take what? 2, but the electrons are finished, so we are done. Hope you understand what I'm saying here. The L shell is supposed to take 8 electrons, but due to the number of electrons we have for oxygen, it took what? 6. So this guy can still take 2 if there is 2. I hope you get the point I'm making here. Good. And since this guy is supposed to take 8 electrons, and it has taken only 6 electrons, it is not satisfied. That means it can take more. I hope you get the point I'm making here. And because that is it's last shell, this is the last shell, because we don't even have more to even go. So this is the last shell. That last shell is also referred to, or what we call the valence shell. I'll be using the valence shell a lot than the last to understand. When I say valence shell, that means the last shell of any atom. Let's try another element, number 19, which is potassium. Like I said, you have to know all your 20 elements with the atomic numbers. Once you know atomic number and understand configuration, you'll be able to write all the configurations of the first 20 elements. So let's go. I'm looking at potassium, which is what? 19. So help me here. Let's go. Electronic configuration. The K shell is going to take how many? 2. We still have 17 more. So this guy will take 8. The N shell will also take what? 8. That gives me 10. That's 18. So the N shell will take what? 1. Remember, this guy is supposed to take how many? 8. And it has taken 1. That means it's not fully filled. We'll use that to do something. When I say fully filled, that means the last shell has not gotten the maximum number of electrons it does or it needs. I hope you understand what I'm saying here. Good. So if that is the case, then once again the N shell becomes potassium's valence shell. I hope you understand it. Okay, so that is the case. That's what I want you to understand here. You understand valence shell, and that's the case. That's what we're looking at. Now, if you don't get the number or the maximum of electrons you have, then the atom is not what? It's not stable. This is a new thing here. This is something you have to know. If I'm supposed to take 8, like potassium is supposed to take 8 for the last shell, but it has taken only 1, then potassium atom is not what? Stable. That means if you are not stable, your last shell is not fully filled. Listen, if your last shell is not fully filled, then you are not what? You are not stable. I hope you understand what I'm saying here. I hope you get the point I'm making here. So stability simply means that your last shell is what? Is fully filled. This guy is not stable. That guy is not stable. And atoms are interested in their stability. They don't joke with it. That is why they will either give out or receive in order for them to be stable. So if I don't have if I need 2 and I don't have, either I'll receive 2 so that I become stable, or I'll give out. That's the thing. An atom must be stable. So if I'm not stable, if my last shell is not fully filled, I have to do something. What would I do? I'll either give out my electron, or receive or gain. Let me use the gain. Or gain what? Gain an electron. Or give it out, or lose it, or gain. I will get the point I'm making. You losing or gaining an electron, for you to become stable, you form what we call an ion. So we are leading you to this point. Some people call ion, no problem. I have no problem with the name, but it's an ion or an ion, no problem. Good. So I'm saying that once you are not stable, that means your last shell is not fully filled, the valence shell is not fully filled, and you either give out or what, or you receive. Under what condition will you give out, or will you receive? That's the next thing. So how do I know this guy is giving out, and how do I know this guy is receiving? This is it. Now, if the valence shell, I said whether you give out or receive, you form what? An ion. You get the point I'm making here. If you receive, you become a negative ion. So if you gain electron, you become negative what? Ion, a negative ion, and we call you an anion. You are an anion. But if you lose electron or you lost your electron, then you become what? A positive. So it's like when you give out, you are positive. So positive, we call that what? A cation. So anions are what? And atoms are atoms that have what? That have gained electrons in order to be what? Stable. What's an ion? An ion is a charged particle, or it's an atom that has either lost or gained electron in order to become what? Stable. How do you understand what I'm saying here? How are we getting the point I'm making here? Very important. Very important what I'm doing. Very key. I don't know if you see a transition here. So after talking about the electronic configuration, now we are linking it to what? To ion. These are the things you need before I can teach you how to write the name of any compound. You need to understand all these. Very important. Okay, so now we have gotten to what we are gaining and loss of electrons. So when you gain, you become an anion. When you lose, you become what? A cation, which is positively charged. The next question, under what circumstance would I give out an electron or would I gain? That's the next thing. Under what circumstance would I do that? Under what circumstance, when will an atom give out and when will an atom receive in order for it to be stable? Very important. All these are in the notes. So when you get there, make sure you have the notes and follow the reading and be fine. Good. So this is it. Now we are looking at two things here. For me to be stable, for an atom to be stable, when we say you are stable, that means you have fully filled valence shell. I hope you understand this. That means your last shell is full. If you are supposed to take 8, it's taking your 8. If you are supposed to take whatever, it's taking your 2. We call that the doublet and the octet rule. And about that for chemistry students. We'll go deep into that for them later here on this same channel. We'll do chemistry for all chemistry students. Good. So let's go. So we have this. Now, if your valence shell and the electron on the valence shell will definitely become what? The valence electron. So the last shell is the valence shell, and the electron on the last shell is the valence electron. I want to use that to explain something. If your valence electron is 1, 2, 3, then you are to give out. I ask the question. So if I'm supposed to give or get, under what circumstance do I give an electron? Now, what circumstance do I receive an electron? I'm giving the circumstance that if you are 1, 2, or 3, bro, you are going to give out. Give it out and be what? And be stable. So these guys will lose, or they will what? The electrons are lost from here. There's loss of what? Electron. So for this one, loss of what? Electron. So you lose the electron when your valence electrons are what? 1, 2, and 3. I hope you get it. Example, let's take aluminium, Al. And aluminium is number 13, Al13. Let's try the electronic configuration. You will give out. I said when you give out from here, you become a cation and you carry a plus sign. Plus whatever you give out. The number of electrons you give out, that is a plus for you. Good. So this gives me 2. This is aluminium atom. Aluminium atom. Good. 2, 8, 3. Share. Aluminium falls within this. So in this state, aluminium is not stable. Why is it not stable? The valence shell is not fully filled. So since the valence shell is not fully filled, then bro, you have to give it out. So aluminium gives that out, and aluminium becomes aluminium 13. Then we have 3 plus, now 2, 8. So this is the electronic configuration for aluminium 3 plus. So this now becomes aluminium ion. It's no longer aluminium atom. In this state, it is the aluminium atom, which is not stable. You should know why by now. Then aluminium had to give out this one. Like I said, when you are 1, 2, 3 give out, aluminium giving out means that it now becomes an ion. But how do we define ion? It's an atom that has lost or gained electron to be stable. An atom that has lost or gained. In aluminium's case, it had what? It had to lose that electron. So it lost that electron in order to become stable. So this electronic configuration for who? For aluminium. I hope you get the point I'm making here. I hope you understand what I'm saying. Good. Very important. Then if your electron number is 5, 6, or 7, you receive. So for that one you gain. If your valence electron is what? 5, 6, and 7. For these guys, they will gain what? Electrons. they will gain electrons. I hope you get the point I'm making. They gain electrons. Good. Once they gain electrons, they become what? Anions or negatively charged. Let's try Cl, chlorine, Cl, and that's number 17. So this chlorine atom, and its electronic configuration is what? 2, 8, that's 10, 7. The valence shell is still not fully filled. That means chlorine atom is not stable. Yes, it is neutral, but it's not what? Stable. Neutrality is different from stability. When we say it's neutral, that means that the number of electrons are the same as the protons, so it's neutral. But stability means that your last shell is not fully filled. So since the last shell is not fully filled, then what are you supposed to do? You're either giving out or receiving. In this case, I said if you have 5, 6, 7, then you are receiving or you gain. So chlorine must gain. And when chlorine gains, it becomes Cl, still 17, but Cl minus. It's supposed to be minus, but normally put the 1 there. So Cl minus means you have gained 1. And the configuration now becomes 2, 8, what? 8. So this is chlorine in its stable form. This chlorine ion, and it's an anion. So there's a difference. This chlorine atom, and this chlorine what? Ion. This aluminium atom, and this what? This aluminium what? Ion. I want to get a difference so you know that when I write with it, they're meant to carry a charge, you're an ion or you're an ion. I hope you have understood this. I hope you get the point I'm making here. Now that we know that Cl is there, aluminium is what? We say aluminium forms an ion which is 3+, and Cl forms an which is -1. Now, this charge you are carrying, when I take the number part of the charge you are carrying, it becomes your valency. Oh, listen once again. Look at the transition. Now, what I'm looking at here is now what we call valency. Now, valency is the combining power of an element. When this guy wants to combine with this guy to form a compound, you need to show your valency. What power are you contributing? So the combining power, this one has a power of what? 3 and -3 and 1 without the what? The charges. So don't take positive, don't take negative. When you take the number with the charge, it becomes a different, that's oxidation state of the element. But we're not looking at that now. We are looking at just the number, and that becomes what? The valency. So the valency of aluminium is what? Is 3. I hope you get the point I'm making here. I hope you understand what I'm saying. And the valency of what? Of chlorine will be what? Will be 1, because it needs 1 more to what? To fill its shell. I hope you understand what I'm trying to say here. You get the point. So what is now we've learned what valency is. And when we look at the way compounds are formed, the next thing here is the formation of compounds. And compounds be formed when there's an interchange in what? In the valencies. I hope you get the point I'm making. I'm building a point here before we can name the compound. How are the compounds even formed? So we look at the formation of what? Of a compound. And before you can know how to form compound, then you need to understand what valency is. How do you know what valency is? If you don't know how to write electronic configuration, you don't know how to write the valency. So from the electronic configuration, I was able to know whether this guy will give out or receive. And I was able to know that this guy will now receive. He receiving one gave me an idea of his what? Valency. This guy giving out 3 gave me an idea of his what? Valency. So you see the way the thing started. If you don't know all those things, and I just come and write aluminum 3+, where is the 3+ coming from? Where is this coming from? But since you know that I know this is number 13, so I wrote down its electronic configuration. As I wrote the electronic configuration, then I had to know that the last shell needs 5 more. But when you're within 1, 2, and 3, you need to give out. So it gave out. Then I choose the number as is valency. I hope you understand what I'm saying here. Good. So the next thing I'm looking at is formation of the compound. How the compounds are formed. How compounds are formed. Look at that. How compounds are formed. How the compounds are formed. So formation of what? Of compounds. Formation of compounds. Formation of compounds. Now what's a compound? A compound is a substance formed by the chemical combination of 2 or more elements. I still like to use NaCl and that to demonstrate what compounds or how we form compounds. So we say a compound is formed from the combination, for the chemical combination. That chemical combination is when there is the exchange of the valencies. So we are looking at sodium, Na, and what? And Cl. Let's look at something. Let's try and form a compound out of this. Now sodium is number 11 and chlorine is number 17. Help me write the electronic configuration for this guy. Electronic configuration gives me what? Gives me 2, 8, 1. Then configuration of this will give me what? Will give me 2, 8, 7. Now, when this happens, this guy must give out its 1, and this guy will receive 1. So sodium now forms an ion which is sodium plus, and chlorine form what? Cl minus. Now we want to combine this. Do you remember this guy has 1 and that guy has 1? I said a compound is formed or the substance formed from the chemical combination. That chemical combination, the chemical combination here, is basically the interchange or the exchange or interchange of what? Of valencies between the atoms involved. That means before they can combine, we change. I give you a valence, you give my valence, your valence, that's all. I give you mine, you give me yours. So in Na plus, I just want to put the 1 here for learning's sake. Man. We don't need to put the 1 here. We are saying that if you want to combine and form a substance, there need to be the interchange of valence. So this one will give its valency to this, and this also gives its valency to that. And then they will get something like Na1, where the 1 is coming from chlorine, then Cl1. The plus and the minus will cancel each other, and they go to what? 0. So plus and minus goes to 0. Now this 1 can cancel that 1, and now we form NaCl. So this is the compound. We form this compound by interchanging their what? Their valences. Let's try aluminium and oxygen. Aluminium, let's take Al. So this is Al and number what? 13. And this is O and number 8. Let's try write down the electronic configuration of aluminium. Electronic configuration of what? Of aluminium is what? Is we have 2, we have 8, and we have what? 3. That means aluminum is supposed to give out what? 3. So aluminum becomes Al. You know why it's giving out 3? Because its valence shell is not fully filled and it's between 1, 2, and 3. So we give out. Good. So this one gives us 3 what? 3 plus. Then this one has 2, 6. This one needs what? Needs 2 more to be stable. So it receives 2. That means we are going to get O2 what? Minus. Now I want to form a compound out of this. A compound, a substance that form should be a chemical combination between this and this. In combine them chemically, they need to interchange their what? Their valences. So I'll get Al3 plus, then O2 minus. I want to combine this. They said they will change their valences to interchange. So this one's valency will drop here. This one's valency will drop here. That gives me Al2O3. The plus and minus will take care of themselves, so it becomes what? 0. This is aluminium oxide. This aluminium oxide. So I have formed a compound by knowing the electronic configuration, atomic number, the ions, and all that. This is a summary of what we are going to do. We are going straight away. Good. So that is basically how to write the chemical formula or how to form chemical formulas. So when I give you the chemical formula to form, you should be able to get the elements right out of electronic configuration and make sure you can what? You can form that compound. I hope you get the point you are making here. Good. Now that we form compounds, now let's look at what the chemical formula is. So what we have formed here, now this is a chemical formula. This is the chemical formula. Isn't this thing beautiful? That we want to get the chemical compound. Now after getting out the chemical formula, what we have written down is a chemical formula. What is a chemical formula then? What is it? Now let's look at it straight here. A chemical formula expresses I like this definition so much. It expresses the number of atoms of the different elements forming the compound. What this means is that if you look at this, we have 2 elements. We have aluminium and what? Oxygen. But we have 2 atoms of aluminium. This 2 means that we have 2 of the aluminium and 3 of the oxygen. That's what this thing means. So a chemical formula gives me 2 information. It gives me the number of atoms of the different elements. First of all, it tells me the elements present. So I have aluminium and what? And the oxygen present. How many of the aluminium do we have? And how many of the oxygen do we have? That is what a chemical formula does. So if I ask to define a chemical formula, then I'm standing here that it's giving me 2 information. What are the informations? It tells me the elements present and the number of what? Elements present in that particular what? Compound. So the definition says this: a chemical formula expresses the number of atoms of the number of atoms of the different elements forming the compound. Very, very well important. So I'm giving an example. In this case, we have two elements, one sodium, one chlorine. So it's just two elements, two atoms. I hope you understand what I'm saying here. Good. So now that we know what the chemical formula is, let's see how to write the names of the chemical formulas. How to write the names of the chemical formulas. And for us to do that, we'll do that in the next class so that we can write the names. So for today, sit well and go through this. By the next video, make sure you watch the next video and get how to write the chemical formulas. Then from there, we'll start naming the compounds so that you understand it better. Sit down once again, go through all this. If you have any question in the comment section, send them to me and I'm going to answer all. Thank you very much for joining this class. Don't forget, there are a lot of people writing the BEC. So like this, subscribe, and share to all of them. Thank you very much.